thing. So a system, when they talk about systems of equations, remember a system is just two or more equations. So you're going to have like two equations in standard form or in slope-intercept form, never really in point-slope form, but standard or slope-intercept, you can get them in either one of those forms. You're just looking for a solution, an x and y value that makes all of your equations true. So normally we're used to just like solve for y on one equation, and then we can plug in a value for x and we'd get a value for y. Now we want all of the equations in the problem to have an x and a y that will make them both true, okay? So that's the goal here. There are three different types of systems that we're gonna talk about. And I gave you pictures of all three, but we're gonna just talk a little bit about them. One type of system would be you graph your two lines and they meet at one point. And we call that independent. Okay, which means you will have one solution. And that one solution is going to be a point, some x value and y value. Okay, you'll have one solution if they just intersect at one point. Your solution, you guys, is this right here. Wherever they met is your answer. Okay, that's the point that we're going to give as the answer. So that's the one that's most common. You'll see that most of the time. The second one is coinciding lines, meaning they are the same line. So it is not two separate lines, it will be the same line. And we call that dependent. Okay, and for dependent, your solution is infinitely many. You have infinite solutions, meaning you're working with the same lines. This line and this line match up perfectly. All of the points on them are a solution then, okay? So the same line means you have infinite solutions. And then the last one is if the lines are parallel. How many solutions do you have if your lines are parallel? None. There are no solutions, right? We call this inconsistent. There is no solution when your lines are parallel. Okay. Questions on any of those three? I'm less concerned, like independent, dependent, inconsistent. I'm less concerned with that. I'm more concerned that you know there's one solution, there's infinitely many, or there's no solution on these types of problems. But they will ask you at times, like, is this independent, dependent, or inconsistent? So just be clear which one goes with which on that. Okay.
I have a question.
Yes, I have an answer, I think.
If you had like two parabolas and like one was upside down, they would intersect at 2 points. Would that include
Right, these are linear equations. So these are all going to be straight lines. But yes, that is true that if you have two parabolas intersecting, you would have 2 points. We don't actually ever do that in Algebra 2, but down the road, you may do that. I like the question though. Okay, so we are gonna do some solving by graphing, and I made these two different colors so that you could see which line is my black line and which line is my red line. So I'm gonna color code like that. You don't have to, but just for the sake of being clear with you, I'm gonna do black and red as my two lines here, okay? You guys know how to do this. This should be super easy for you. How do you graph y equals x minus 1? Where do you move first? Down one, right? Y-intercept first, so down 1. And then from there, what is your slope? Up 1 over 1, right? If there's nothing out in front, we're going up 1 over 1, up 1 over 1. You can do that as many times as you want. You really only need 2. So your line is going to be like that. Okay, and these are super important that you're accurate. So if I were you, I would use a straight edge when I'm doing these, or if you're doing it in Notability, wait for the line to straighten out for you, right? You'll see in a minute here why this matters. My second line, y equals a negative x plus 3, where do I move for that plus 3?
Up 3.
Yes, now some of you are going to be tempted to move to the right 3, because you're going to think of it as an x-intercept. This is always a y-intercept. Remember, your y-axis is the vertical one. So make sure you're going up and down when you're plotting your y-intercept. So up 3 from 0, 0, not from the old line. This is a new line. 1, 2, 3 is right here. And then where do I move for the slope?
Down one over one.
Down one to the right one, down one to the right one. Look what just happened. This is why I do a lot, because if you do multiple, you usually get to your point. My answer is that point. What is that point?
2, 1.
2, 1. We went 2 to the right and 1 up. So to solve by graphing, my solution is 2, 1. That means I can plug a 2 in for x and I will get a 1 for y. Plug a 2 in for x and I will get a 1 for y every time. Okay, that is our solution. It's what makes both those equations true. Questions on that? Okay. Letter B. These are in a slightly different form now. Here's the thing. You could turn this into slope-intercept form and graph it that way, and it would still work. Sometimes it's not as pretty when you try to turn it into slope-intercept. This one would be fine because you have 2s and 4s, and those work out nicely. But what's the quicker, easier way to graph this one right now? Cover up. Right. So for the black line, I would say 2x equals 4, right? 2x equals 4, and y equals 4. Well, solve for my x, divide by 2, so x is 2. Okay, so I get these two equations. Those are not equations of lines right now, right? Those are my intercepts. So I'm going to say my y is at 4, so up 4 is going to put a point right there. My x is at 2, so where I hit the x-axis is 2. And now your line is just connecting those two. Okay. My second equation, I have two equations again. X equals 2, so that one's done. And then it's negative y equals 2, but we need to get that negative out of there. So divide by negative 1, and you get y equals negative 2. And now we plot it. Sorry, I should have stayed with black this whole way through. This one was the black line. The red line has an x-intercept of 2 right here. So there's your answer, right? Because it hits the same. And then y equals negative 2 is here. So here's my second line, which means my solution is what? Name that point of intersection. What is this point? 2, 0. So that's your answer. 2, 0 will be your solution. Okay. Any questions on that? Okay. Talk me through this one. You did this, right? You just did this on your test, just not with 2 equations. You did it one at a time. What is x equals negative 4? What kind of line? That's a vertical line, right? Where is x always negative 4? 1, 2, 3, negative 4, 0, negative 4, 1, negative 4, 2, negative 4, 3, right? X is always negative 4 on this line. So that's my first one. Then we have y equals 1. Where is y always equal to 1? What kind of line? That one's horizontal at 1, where y is 1, 0, 1, 1, 1, 2, 1, right? That's this line. So what is my solution? Negative 4, 1. Look how pretty that is. You had an x value of negative 4 and a y value of 1. So if you have a horizontal and vertical like that, you have your answer right there. Negative 4, 1. Okay. Okay. Last thing, graphing wise for this one, is letter D. And I want you to try this one on your own. I'll tell you right now, the black line, you don't want to do the cover-up method because you end up with 8/3, negative 8/3, which is a funky number, okay? So I would not do cover-up method here. For this one, I would put it into slope-intercept form, okay? So turn that one into slope-intercept. This one, you can either do slope-intercept or the cover-up method. Try whichever method you like better. But solve both of those, see what you get. I'm going to come around and take a gander as you solve. Let me know if you have any questions. I should pause this. I unpaused. Did you get an answer?
Yeah.
What'd you get?
-4, -2.
-4, -2. Good. Anybody else get that? Let's look at the black line first, okay? First thing you should do is add 3x to both sides. So you get 2y equals 3x plus 8, okay? Then divide by 2. So you get y equals 3/2 x plus 4. Okay, so if we graph that, you need to go up 4. 1, 2, 3, 4. And then it's a slope of 3/2. So you're going to go up 3, 1, 2, 3, to the right 2. Okay, and if I were you, like I said, you could just draw the line. I like to just keep going with it. So I would go down 3 to the left 2 to keep my slope going, down 3 to the left 2, just to get a really straight line. So that's going to look something like this. Okay, did you do cover up or slope intercept for the second one? We did both. Okay, well, I'm going to do cover up just because I feel like it's pretty quick. X equals -8 is 1. So 1, 2, 3, 4, 5, 6, 7, 8. And then 2y equals -8, divide by 2. So you get y equals -4. Okay, so those are your intercepts. -8 and -4. Okay, and when you draw that in, you go right through this point here, which is your answer, which is -4, -2. Questions on that? Lots of graphing in this lesson, okay? Hopefully that's a good thing. Okay, last thing for this lesson. We are going to do a little bit of classifying, but without graphing this time. So when you classify without graphing, I gave you your little cheat sheet right there. Independent means they're intersecting lines. Dependent means they're the same line. Inconsistent means they're parallel lines, right? So that's those pictures that we talked about at the beginning of the lesson. You need to put your equations into the same form to figure that out. So the best form I would say is slope-intercept because you can see your slope and you can see your y-intercept. So we're going to turn everything into slope-intercept form. What do we have to do to the first equation to get slope-intercept form? Nothing. It's already there, right? So we're going to leave that one alone. What do we have to do to the second equation?
Subtract 6x.
Yeah, we're going to take away 6x first. So you have -3y equals -6x plus 9. And then divide by -3 everywhere. Make sure you do it everywhere or it's going to throw things off. So you get y equals, this would be 2x minus 3. So look at your two equations. Independent, dependent, or inconsistent? Dependent, right? That's the same line. When they are identical, same slope, same y-intercept, excuse me, that is dependent. Okay, we are talking about the same line here. Questions on that? Okay, you do letter B then. Two lines there. Solve, you only have to change one of them, right? Just the top one needs to be adjusted a bit. See what you get. Bless you. For letter B.
Y equals inconsistent.
Inconsistent. Why inconsistent?
It's parallel.
They're parallel. How do you know they're parallel? Same slope, but a different y-intercept. Okay, so if we rearrange this one, you would take away 8x, so -4y equals -8x plus 20, right? Divide by -4, and you get y equals 2x minus 5. Okay, so here's your two equations, 2x plus 3 and 2x minus 5. If they have the same slope, but a different y-intercept, that means those are parallel lines. So we would say this is inconsistent. Right, lines are parallel. Questions on that?